WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO Candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Hello students, you're welcome to Eko Learners Support for WAEC and NECO candidates. I'm going to be your physics instructor for today's lesson. Today, we'll be talking about
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
electric charges. Come along with me and let's check out the learning objectives. By the end of the lesson today, you as a student will be able to define electric charge and list types of electric charge. Secondly, you'll be able to list the properties of electric lines of force. And lastly, you'll be able to state the law of electric charge. Electric charge. Electric charge is nothing but the amount of energy or electrons that pass from one body to another by different modes, like conduction, induction, or other specific methods. Charges are present in almost every type of body. Neutrally charged bodies have no charges, and the standard unit of electric charge is coulomb, and others are microcoulomb and millicoulomb. Mathematically, a charge is the number of electrons multiplied by the charge of one electron, and symbolically it is written as Q is equal to Ne, where Q is a charge, N is a number of electrons, and E is a charge on one electron, and it is denoted by 1.6 times 10 raised to the power minus 19 coulomb. Types of electric charge. There are two major types of electric charges, and they are positive charge and negative charge. When an object has more electrons than proton, it is called a negative charge, while a positive charge occurs when an atom has more protons than electrons. And when it has equal number of electrons and protons, the body is said to be electrically neutral. As you can see from the diagram, electrons have a negative charge, which we have here, and protons have a positive charge, and like I told you earlier on, net charge is equal proton and electrons, and the diagram here depicts what we have just said. Production of charges. There are three ways of producing charges, namely by friction, by induction, and by conduction. In order to charge an object, the charge balance of positive and negative charges will be altered. Let's look at this diagram together. This first diagram depicts charging by friction. When a glass rod is brought near a silk, the glass rod is positively charged, and this silk now gains the electron, which is what? Negatively charged. For induction, we have two bodies, A and B. In this, here is showing no charge. And by the time we bring them together, it shows that A has negative charge, while B has positive charge. And they are being brought together. And you can see when they are separated, they also have their charges retained. And this is what we have here eventually. For conduction, this is a rod that is being brought near another body. And as you can see, it has negative charge. So for conduction, it needs to be what? Nearer to the, it has to touch the other objects. And we said for an object to be charged, the positive and the negative charges will need to be altered. What are the properties of electric charge? Charge is a scalar quantity. It also transfers from one body to another, which means they are movable. Like charges repel each other, and unlike charges attract each other. And charge is always linked with mass, just as we have here, the properties being explained with the aid of a diagram. Electric lines of force. Electric lines of force, also known as electric field lines, are imaginary lines that emerge from positive charge and enter negative charges. They represent the direction and strength of an electric field around a charged object or in a region of space. What are examples of electric line of force? They are radial lines around a point charge. There are lines between parallel plates when we are talking about capacitors, lines around a charged sphere, and lines in a capacitor. Properties of electric field lines. These lines, as you can see, we told you they are imaginary lines. They never intersect each other. The field lines are perpendicular to the surface of the charge. And the magnitude of the charge and the number of field lines both are proportional to each other. So when you are having this diagram, you need to take cognizance of the distances. The start point of the field lines is at the positive, which you can see as the arrow head depicts. Starting point is always at the positive charge and ends on the negative. And that is what we have here. It's coming from the positive down to the negative. So you need to take cognizance of the arrow head to show the direction, like we mentioned earlier on. So for the field lines to either start or end at infinity, a single charge must be used. Loss of electric charge. It states that positive charges repel each other, negative charges repel each other, but opposite charges attract. Just like we have in the diagram, this is negative, positive charge and negative charge. So when we have positive and negative, there is room for what? Attraction. When we have positive and positive, there is repulsion. When we have negative and negative, there is repulsion. And this diagram also shows the same thing. There is repulsion. You can see the sign, the red balls are moving sideways to show it is the same charge. The same thing for positive charges, they are moving sideways. And neutral, that means they have equal amount of protons and electrons. And here, there is attraction because they are negative charges. They don't have the same charge. So opposite charges attract, the same charge repels. So I believe during the course of the lesson, and as we are at the end of the lesson, you should be able to list 4 properties of electric charge. Do that while I come back for the answer with you. Welcome back. So let's list the 4 properties of electric charge. Charge is a scalar quantity because it has magnitude. Charge transfer from one body to another. Charge is transferred from one body to another, which means they are movable. Like charges repel each other and unlike charges attract each other. Charge is always linked with mass.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
For your observations, comments or questions, kindly visit our social media handles that is posted on the screen. See you next time and thank you for your time.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.
Hello students, you're welcome to Eko Learners Support for WAEC and NECO candidates. Hi, I'm going to be your physics instructor for today's lesson. Come along with me.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
For today's lesson, we'll be taking heat transfer. Let's look at the learning objectives together. By the end of the lesson, you as a student will be able to define heat transfer, state the modes of heat transfer, explain the application of heat transfer. Heat transfer. Heat transfer is the transfer of thermal energy from one body to another. The rate of heat transfer depends on temperature difference between two materials. The greater this difference, the higher the rate of heat transfer. Examples are heat from the sun warming your face. Secondly, reheating a cold cup of coffee in a microwave oven. Thirdly, heat transfers into your hands as you hold a cup of hot coffee. Touching a stove and being burned, or ice cooling down your hand. And lastly, the heat from a heater. Causes of heat transfer. Experiment shows that the heat transfer to or from a substance depends on three factors, which are the change in the substance temperature, the mass of the substance, and certain physical properties related to the phase of the substance. As you can see, we have radiation from the sun, we have conduction, we have convection. These are modes of heat transfer. Let's check in the next slide. Modes of heat transfer. We have conduction, convection, and radiation. Conduction, this is the direct transfer of heat between particles in physical contact. Examples are a metal spoon in a hot cup of coffee. Then we have heat is transferred also through walls of our houses, or our schools, or our churches, or mosques. Then we have convection. This is the transfer of heat through the movement of fluids. Examples are ocean currents, where we have the land and sea breezes, then atmospheric circulation, and heat is also transferred in what? In heat transfer in buildings. Radiation. This is the transfer of heat through electromagnetic waves. For example, solar radiation or heat transfer from a fire. And this diagram here shows the modes of heat transfer in one similar occasion, where we have a pot of water on the heater itself, and you can see the person holding it feels the radiation, the heat radiating without touching it. But for conduction, he has to touch the cup on the heater. And for convection, it is what? It is in the process of the liquid itself. Application of convection. We have the heating of water on a stove, which is the diagram we have here. We have ventilators provided at the top of room, which allows stale and hotter air to escape. We have this in factories. We have the ventilators is mostly used in factories or warehouses. Then we have use of chimneys. In factories, the smoke and hot gases being lighter rise up and escape out through the chimneys. Application of radiation. One of the most common and beneficial application of heat transfer by radiation is solar energy. Solar panels and collectors use the radiation from the sun to generate electricity or heat water. The radiation is absorbed by the surface of the panels, which converts it into electrical or thermal energy. Other applications of radiation includes for medical uses, for those that are going for chemotherapy and the others. We have academic and scientific applications. We have industrial uses, and we also have it in nuclear power plants. And this is also an example of radiation. You can see that the person does not actually have to touch the fire. You can feel the radiation of the heat from the fire without touching it. Application of conduction. We cook food in vessels made up of metals. And when we also iron our dresses, it is transferred from the iron to the cloth to smoothen the wrinkled parts. Then we also have the handles of our cooking utensils. That is why they are made of plastic or wood, because they are poor conductors of heat. If it is made of metal, definitely we are going to feel the wrath of the heat on our palms. Then the temperature inside the igloo, which is a snow house, is warm because snow is a poor conductor of heat. And this is an example of what we have here. You can see that the turning spoon is also made of wood instead of metal, and the handle is also made of what? Plastic. But the source of itself is made of a metal, which conducts heat. So application of heat transfer. In engineering, it helps in the designing of heating and cooling systems and other thermal insulation. Medicine is used in the treatment of injuries and cancer treatments. While in our environment, it helps us to know climate change and for weather patterns. Practice question. I believe during the course of the lesson, you will be able to briefly explain the 3 modes of heat transfer. I'll give you some seconds to do that. I'll be right back.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Welcome back. So I believe from the class we had today, you as a student will explain the 3 modes of heat transfer as follows. The 3 modes of heat transfer are conduction, convection, and radiation. Conduction, we said, is the direct transfer of heat between particles in physical contact. That is the key word there, physical contact. And an example is a metal spoon in a hot cup of coffee, or heat transfer through the walls. Convection, which is the second mode of heat transfer, we said it transfers it through the movement of fluids. So this occurs in the fluid itself as heat is being applied to it. Now we have the land and sea breeze. We also have atmospheric circulation and heat transfers in buildings. And for radiation, we said it's the transfer of heat through electromagnetic waves. And a very typical example is solar. So we have solar radiation and heat transfer from any source of fire. Thank you.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
For watching. For further questions, observations, suggestions, kindly go through our social media links on the screen and put up your comments there, your observation or your questions. Thank you for staying with us today. See you next time.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.